Dear students, this is Shivu.b physics lecturer from Minority Moraji Desai Residential PU College, Raichur. Dear students, today we are going to discuss in this video that is Coulomb's law. First we have to understand the statement of Coulomb's law. First statement for this one. Statement. The force between the 2 point charges is directly proportional to the product of magnitude of the charges and inversely proportional to the square of the distance between them. The statement was given by Coulomb, therefore we can call this is the Coulomb's law. Okay, so now we have to write the force between 2 point charges is directly proportional to the magnitude of charges and inversely proportional to square of distance between them. This is the statement is given by Coulomb. Okay, clear? This is the statement. They can ask for 1 mark also. State the Coulomb's law only. It's enough. At the time you have to write the force between the 2 point charges is directly proportional to the product of magnitude of the two charges and inversely proportional to the square of the distance between them. Just this is the statement given by Coulomb. So then we are going to explanation about Coulomb's law. Explanation about Coulomb's law. First, here we consider two charges. This is one charge. This is also another charge. Here I am giving the name for this charge is Q1. This is also charge is Q2. Here force, it may be attraction or repulsion. We know that when the force which is repulse, when we consider same kind of the charges. When the force which is attract, when we consider opposite of kind of the charges. But in here explanation purpose I consider two same kind of the charges Q1 as well as Q2. These two charges are separated by a distance r. Okay. These two charges are kept in air medium. Okay. So because of I have mentioned here air medium, the force which changes when two charges are kept in the another medium, right? Okay. So for explanation, just you have to write, consider two charges Q1 and Q2. These two charges are separated by a distance is r. F represents force between them. According to Coulomb's law, according to Coulomb's law, that is, force is directly proportional to the product of magnitude of two charges. Directly proportional to the product of magnitude of the two charges. Just we represent this is equation number 1. Then again the force is also inversely proportional to the square of the distance between them. This is equation number 2. According to statement I written here two equations. See here. the force between the 2 point charges is directly proportional to the magnitude of the product of magnitude of the charges and inversely proportional to the square of the distance between them. Just make here the proportional to the product of magnitude of the charges and inversely proportional to the square of the distance between product of magnitude of two charges q1 and q2 and here inversely proportional to the square of distance from combine equation number 1 and 2. Combine equation number 1 and equation number 2. Then this equation becomes, that is F is directly proportional to the product of charges q1 and q2 divided by r square. Here one proportional constant which is introduced here, that is F is equal to K product, that is q1 q2 divided by r square, right? So here r square where k value is 1 divided by 4 pi epsilon naught. Then this equation becomes here F is equal to 1 by 4 pi epsilon naught product, that is q1 q2 divided by r square. Okay, it's enough. If they are asking question, state and explain the Coulomb's law. At the time you have to write statement for Coulomb's law, then explanation. The final equation you have to get, that is F is equal to 1 divided by 4 pi epsilon naught q1 q2 divided by r square. It's enough for 3 marks. In PU board they can ask for 3 marks. It's enough. Statement and explanation. As F is equal to 1 by 4 pi epsilon naught q1 q2 divided by r square. Okay, this is state and explain the Coulomb's law. Okay, then we will discuss with another concept. Here in this equation we represent epsilon naught, right? Epsilon naught represents, it is a permittivity of the free space. We are discussing here permittivity of the free space. In this Coulomb's electrostatic force, F is equal to 1 by 4 pi epsilon naught q1 q2 divided by r square, right? Where epsilon naught in that equation, this is permittivity of free space. Permittivity of this is free space. We have the one of this constant value, this epsilon naught value, we know that. It is epsilon naught is equal to, it is a standard value, 8.854 into 10 to the power minus 12. So unit, we are not bothering about the units. Once we know that the formula F is equal to 1 divided by 4 pi epsilon naught q1 q2 divided by r square, once we know that, easily we can write its formula. If epsilon naught, keep this one here, F keep this here at the place of epsilon naught, then here 2 coulombs, Coulomb, it becomes Coulomb square, and for force for Newton and for meter square. Coulomb square for Newton and meter power minus 2. Okay, this is epsilon naught constant value. When we solving the problems, if they are not given epsilon naught value, so you have to remember its value, epsilon naught value is 8.854 into 10 to the power 8.854 into 10 to the power minus 12 Coulomb square for Newton and for meter square minus meter square. This is okay.
this is about astronaut. Okay, one also you have to remember here for solving the problems. It's enough for 3 marks, but here we have to discuss extra about this. If they are asking find out the force between the two charges, they are given the four charges. One is 2 Coulomb and Q2 is 4 Coulomb. Then separated by distance is 2 meter, whatever it may be. At the time you know the value Q1 is value, Q2 value as well as R value. But we don't know about that is 1 divided 4 pi epsilon naught value. So it is also one of the standard value, that is 1 by 4 pi epsilon naught value. So directly we can write that one 9 into 10 to the power 9. If the 1 by 4 pi epsilon naught value is 9 into 10 to the power 9. Let us see how it comes. That is 1 by 4 pi epsilon naught is equal to 9 into 10 to the power 9. Okay, this is about Coulomb's law. So then we are discussing some more concept here. Note points. Okay. Okay, we have to discuss some note points. Note points means it is a knowledge point of view, which are useful for solving problems. Also is useful for to remember the units like this. First first one, how to find out the SI unit of epsilon naught. Means epsilon naught means what? Permittivity of the free space. In this equation, that is Coulomb's law, that is 1 divided by 4 pi epsilon naught Q1 Q2 divided by R square. You can take magnitude, right? So here question is how to find the SI unit of epsilon naught. SI unit of epsilon naught. SI unit of epsilon naught. Okay, so we are going to find out the SI unit of epsilon naught. Keep this one epsilon naught here at the epsilon naught is equal to 1 divided by 4 pi. It becomes here F is equal to F into Q1 Q2 divided by R square, right? Here epsilon naught is equal to, so here 1 by 4 pi constant value. It is a dimensionless as well as unitless. Okay, Coulomb and Coulomb. One charge for C, another charge for C. Because of SI unit of charge is Coulomb. In the previous video we discussed, right? So force unit is Newton and meter distance unit is meter. But here we have R square. Therefore it becomes what? Meter square. Finally, SI unit of epsilon naught we can write Coulomb square for Newton for meter square. This is SI unit. We can write epsilon naught value, that is epsilon naught is equal to 8.854 into 10 to the power minus 12 Coulomb square for Newton for meter square. This is for meter square. So this is just an idea about how to find out the unit of epsilon naught. Easily we can, once we remember the electrostatic force, easily we can find out the SI, that is SI unit of permittivity of the free space. So also another example right? Explain, that is value of 1 by 4 pi epsilon naught value becomes written, that is 9 into 10 to the power 9, right? Here we can write force formula. Here we have that is F is equal to 1 divided by 4 pi epsilon naught Q1 Q2 divided by R square. F is equal to 1 divided by 4 and 5 value is 22 by 7, right? So its value becomes 3.142. In option not value, just we find out that is constant value 8.854 into 10 to the power minus 12 this is. Again here we have q1 q2 divided by r square. Then f is equal to then 1 divided by, okay, here q1 q2 divided by r square. So I don't have calculator. Its value becomes here 311.277 into 10 to the power minus 12. So this 10 to the power of minus 12, it will go upside, that is f is equal to 1 divided by 0.277, it becomes here, it becomes 0.0, its value is 0.00898 into 10 to the power minus, it becomes what? Plus. Okay, here again we have q1 q2 divided by r square, right? So here shift digit here 1 2 3, here f is equal to 8.98 into 10 to the power, you are shifting 3 digit here 1 2 3, 10 to the power minus 2, it becomes here plus 2, it becomes 10 to the power 9 q1 q2 divided by r square. So in generally we consider its value is 8.98, right? This one here generally we consider this is 9 into 10 to the power 9 q1 q2 divided by r square. If they are given the q1 value and q2 value as well as distance, easily we can calculate the force between them by knowing the constant value, that is 1/4 approximate value is 9 into 10 to the power 9 q1 q2 divided by r square. This is just we have to know the idea. These are very simple concepts. Okay, then how to find out the dimensional formulas for permittivity of the free space. Those are very useful for solving the CET. All those one question compulsory in dimension. You have to know the first year concept dimensional formulas. How to find out the dimension for the different formulas. And once you know, we get any difficult, you can answer for any difficult questions in CET on dimensional formula. Okay, now next concept, dimensional formula of epsilon naught. Epsilon naught means what? Permittivity of the free space. Okay. So again we know the formula, right? F is equal to 1 divided by 4 pi epsilon naught q1 q2 divided by r square. Okay. So this formula did not leave you up to complete the 2 chapters in electrostatic, right? You have to remember this. F is equal to 1 by 4 pi epsilon naught q1 q2 divided by r square. We are going to find out the dimension formula for epsilon. Here 1 divided by 4 pi f q1 q2 divided by r square, right? So then here epsilon naught is equal to 1 by 4 pi. It is a constant value. It is unitless as well as dimensionless. Okay. So for charge, we know the current definition. It is the rate of charge, that is q by t. Then q is equal to I into t. Then dimension formula for charge is a t, right? Is it right? Okay. Okay, it's constant value. For charge, here for first charge, that is a t, right? For this one, again we have a t for dimension formula for charge. Then force, we know that is force F is equal to what? ma. Then F is equal to m L t minus 2, because L t minus 2 is dimension formula for acceleration, right? Acceleration means what? Velocity by time. Then velocity means what? Distance divided by time. Those are all we learn lot of for definitions in first year. So directly consider here f is equal to mlt minus 2, right? Dimension fall for acceleration lt minus 2. How it becomes? That is for this one for velocity lt minus 1, and again we have t, then it becomes lt minus 2 for dimension formula for acceleration, right? The total for force here m lt minus 2, that one you have to write here. That is m l t minus 2 and remaining r, this is l square, right? Because of r square is there. R square is there, right? Epsilon naught is equal to a into a, it becomes what? A square, t into t square, it have to write in the square bracket. Then here m, here on l, here 2 l's, it becomes l cube and t minus 2. If epsilon naught is equal to, this equation becomes if m inverse, right, and l minus 3 and it minus becomes plus, right? This is t to the power 4 and this is a square, ampere square. So dimensional formula for epsilon naught, m power minus 1, l power minus 3, t power 4 and a power 2. This is dimensional formula for what? Epsilon naught, permittivity of the free space. We have to idea about all the dimensional formulas, those things. Okay. So in the another dimension formula also we can say, that is for epsilon naught, that is Faraday per meter also. Faraday per meter also another unit we can use. This is in the second chapter, that is capacitance and potential in that chapter. So again we can see that C is equal to epsilon naught A divided by D, right? We need epsilon naught here. Epsilon naught is equal to C D divided by A. C, this is the capacitor. Capacitor unit is farad, and distance meter, area meter square. 1 meter get cancelled. Faraday per meter. Also it is also one of the unit for permittivity of the free space. Okay, so you have to remember all those concepts here. Okay, so we discuss some more concept about Coulomb's law. So you have to remember this. It's simple. Blackboard becomes white while writing more. Okay. One of the very important 1 mark question. It repeats many times in PU board question paper. Define 1 Coulomb. Define 1 Coulomb. Define 1 Coulomb. Define 1 Coulomb. Or define unit of charge. Define unit of charge. They can ask like this also. Define SI unit of charge also, again they can ask. Define SI unit of charge. SI unit of charge. They can ask a question in the 3 different way. Define 1 Coulomb and define unit of charge. Define SI unit of charge. Okay, don't write define SI unit of charge. You have to write the Coulomb. Most students making mistake here. Okay, so define means you have to define, right? So again, you have to remember the formula for electrostatic force or Coulombic force. F is equal to 1 by 4 pi epsilon naught, that is Q1 Q2 divided by R square. Then F is equal to, here its value is 9 into 10 to the power 9. So for defining purpose 1 coulomb of charge, we consider unit charges, similar unit charges. Here similar unit charges, let us see here. Q1 is equal to Q2 is equal to 1 coulomb here we consider. As well as these two charges are kept at distance how much, that is R is equal to 1 meter distance. So then this equation becomes here, our equation becomes F is equal to 9 into 10 to the power 9, 1 into 1 divided by 1 square, because of their given unit charges. They are separated by distance how much, this is 1 meter. Then it becomes like this. It experiences a force how much, that is 9 into 10 to the power 9 Newton. Okay. So how to define 1 coulomb? Two same charges, they having magnitude is 1, they are separated by distance is 1 meter. It experience of force is 9 into 10 to the power of 9 Newton. This is called what? Unit of charge or SI unit of charge. Define SI unit of charge definition, right? Here, Coulomb force. This is define SI unit of charge like this. Clear? Two equal charges, they having value is Q is equal to 1. They should be separated distance is 1 meter. At the time it experience of force is 9 into 10 to the power 9 Newton. This is the define. You can define like this. That is define 1 coulomb of charge like this. Okay. So then you can define it here. I will take chalk piece. You can define here. That is define. That is define 1 coulomb. Take here. 1 coulomb of charge, 1 coulomb of charge, 1 coulomb of charge, that when placed at a distance 1 meter, placed at a distance 1 meter from equal and similar charges in vacuum or air. In vacuum, it experiences a force. In vacuum, it experience of force 9 into 10 to the power 9 Newton. This is the definition of SI unit of charge. Clear? 1 coulomb of charge, that when we placed at a distance 1 meter from equal and similar charges in vacuum, it experiences a force 9 into 10 to the power 9 Newton. Like this, we have to define about 1 coulomb of charge. Okay. So like this, we have lot of idea about Coulomb's law. Thank you for watching this video. Thank you and all.